Welcome to another tutorial on MATLAB. In this particular tutorial series, we are looking to the concept related to hybrid electric vehicle and electric vehicles. In this particular video, we will be having a look into different hybrid electric vehicles based on the placement of the motor position. So if you see whatever indicated over here are different motor positions, and we will see how based on different motor position how this architecture changes. And as you already know, right, in the market there are multiple types of hybrid configurations available, either P0, P1, P3 and P4. So based on this, we will see like what is the difference between these architectures and how we get different advantages from the levels of placement of the motor inside this particular system. So you see the blue area that you are able to see are the conventional or the usual architecture of a powertrain. Okay, whatever the blue area that you see right over here, this is the IC engine, and this is the clutch between the transmission and the engine. Along with that, this is the transmission, and with that, you will have this is the differential, so which transfer the power between the two wheels, right? So this is the base architecture that we have available with us. So with this architecture, suppose if I want to create a hybrid electric vehicle, right, I will be using some e-machine and I will be adding power to this entire powertrain, where I will be placing the motors. So there could be multiple positions in which I can place the motor. So let's see based on different positions what are the advantages and disadvantages that we are getting from this particular placement, and how we are adding advantage. Different configurations are having different advantages and disadvantages. So coming to the first mode over here, this is the P0 mode. So in the P0 mode, you will have the engine. You will have the engine over here, and then you need to place the e-machine before the. So this is the motor that you have, and along with that the remaining structure is like you will have the clutch, you have the transmission, and then you will have the differential that you have as per the structure, and then you will have your wheels. So this is the structure for the P0 configuration, and here you can see this clutch detach the main output area. This is the output area, and this is the input power source. So here you can see there is no possibility of having only E mode, only motoring mode, because here if you start the motor right alone, then engine will also rotate. So this is like also rotating the engine also, right? Because of this, only motoring mode is not possible in this case. But if you see engine mode, only engine mode, it is possible, because the motor shafts will be free when you do not give any current to the motor, and in this case engine can rotate, and you will get the output through the transmission through the differential to the wheels. So this is possible. Coming to the EM mode, engine and motoring mode, then this is possible, because at that same moment you will be able to provide additional torque. So this will provide an additional torque. Along with that, you will what it is basically doing, it is just assisting the engine to maintain the torque that it wants to provide. The driver will be able to produce the power or the output from the vehicle that he needs. Because of this, this type of architecture is being used. Mostly this will be assisting the engine. It cannot run in separately in the electric mode. So this is about the P0. If we now place the motor here after the engine, so how the structure will look like. So this is P1. So you will have the engine, okay, then you will have your scene, okay, and you will have your clutch, and then you will have your transmission, and you will have your differential, and then you will have your wheels. So in this case, the disadvantages that we seen in the P0 part, right, is being overcome in this case. So here you can see engine is like not that separated, but what you can also have here, engine and e-machines can rotate differently. Suppose if I want to operate in the engine mode, right? So the shafts will be free for the motor, and it can run in the E mode only. And for the motoring mode, only motoring mode, I think here also it is not possible, because engine also needs to rotate. There is no detached configuration available between the engine and the e-machine. So that is also not possible in this case, and this problem is still existing in this case. And EM mode is also existing in this case. You can operate both in EM mode, and the placement of the motor is only different in these two configurations. There is no much difference between P0 and P1 in case of the power production or the assistance over here. So previously what we seen, engine was getting the assistance from the motor. Now the case is reverse. Engine is providing the assistance to the motor. So here the motor will be little big compared to the existing P0 configuration. So this is the difference between these two. Coming to the P2 configuration. Okay. So here we will have the e-machine. So this is the engine. You will have the clutch, and then you will have the machine or the motor, and then you will have the remaining part. So here you see the motor is being placed. So you will have the transmission here. This is the P2 architecture, and here you can see the disadvantages that we have. Like we cannot enable only motoring mode in both the structure. So because of this, we got a new architecture in which we can operate. So it can operate in the E mode. In E mode or EM mode, it can operate. So it can only operate in the engine mode, and it can also operate only in the motoring mode. So why this is possible? Only motoring mode, because you have a clutch now, which will just disengage the engine and the machine, and you will be able to provide the output in the transmission. So whenever engine wants to rotate with the motor, then you will have this clutch closed, and you will operate in the EM mode. So suppose if you do not want to use the E mode, then you can have this clutch closed, but you do not give any energy over here. Then in that case, you will be operating in the only E mode. But suppose if you want to operate only in the motoring mode, then in that case, you need to detach this clutch, and you just run only in the e-machine mode. So this is possible in this case. So this is the advantage that we get over here. And along with that, as we are more closer to the wheels, right? The power transmission efficiency also increases with the help of this P2 hybrid. So this is the advantages of P2. So next is the P3 architecture. So in the P3 architecture, what you will have the e-machine, then you will have your clutch, you will have, okay, you will not have the e-machine, you will have the engine over here, and you will have the clutch here, and you will have the transmission, and this transmission is also having a motor. So transmission will have the motor, and this will provide the output to the differential, and then you will get it in the wheels. This configuration you can generate with the help of this P3 architecture. And if you see over here, right, so only motoring mode possible because your power is coming from here. So if you just detach this, then you can run in a motoring mode only. Suppose if you want to run on a EM mode, engine and motoring mode both, then you just close this, and you can energize this, then you can operate in the EM mode. If you want only like engine mode, then you just de-energize this one. You just need to connect this one, you will have the only E mode. So here what the advantage is, the motor is being placed inside the transmission, and because of this the transmission losses are also reduced. In this case, you will get better efficiency in this type of architecture. But based on my understanding, if you are placing the motors with the transmission, the structure will become little bit complex, and the control strategy will also be complex. So in this case, this will be a little bit complex architecture and hard to operate. You need a good control logic, but here you are able to minimize the losses that is coming from the transmission side, and you are providing the most efficient torque production in this type of architecture. Yeah, next is the P4. So as you know here, the P4 is the placement of motor here. So now you will have your IC engine, clutch, you will have your transmission, and then you will have your motor, and then you will have your differential, and then you will have your wheels. In this case also, you can operate in only motoring mode by detaching this one. EM mode is also possible. If you give energy here, along with that, you operate the engine. Only E mode is also possible in this case, okay? And that you will be able to transmit only E mode if you detach this and you just operate it with the help of the motor. So this is also possible. So we seen like there are many advantages, disadvantages. Only motoring mode not possible in P1, P0 and P1. As you can see, there is no disconnection possible between the E machine and the engine. And here also the same case. Along with that, what we already are having like three more architecture that we are getting. So P2, P3 and P4, and this is just to increase, like as we are increasing the number like P2, P3 and P4, we are just minimizing the loss that is being produced from the motor side, and we are giving more torque to the wheels so that it can produce the required demand that happened from the driver side. Along with that, the main keynote that you can consider over here is all these are developed based on the existing architecture of a conventional vehicle. With this, like you just are placing the motors in different positions and trying to check how you can operate the vehicle powertrain so that you can produce optimum power based on the driver request. But the base is the IC engine framework, IC engine powertrain framework through which you are creating all this. So this is all about the different structure, how P1, P2, P3 hybrids are there, and what is the difference between all these. So based on the placement of the motor, you can determine. So just consider only the placement of the motor while determining which type of hybrid it is. That is the simple fundamental idea behind this entire structure placement of the motor. So this is all about the different architecture related to the hybrid electric vehicle. In the coming video, we will be having a look into what is the power flow, the entire power flow from the charging to the discharging, and what are the advantages or what are the stages that are being involved while doing this power conversion, and how the power flow works in an electric and in a hybrid electric vehicle, that we will see next. And yeah, that's all about this current video. In case you are liking the channel, please consider subscribing. In case you have any comment or query, please let us know in the comment section. We will try to improvise the content. If you have any suggestion for any new content that you think that we should make, then yeah, please suggest us on the same so that we can provide you a relevant content so that you can improve your knowledge on the same. So have a great day ahead, and thank you for connecting.